Recap of electronic circuit. In our previous video, we delved into the essentials of electronic circuits, understanding their components and how they interact to perform various functions. As we build on that foundation, let's now shift our focus to an essential aspect of circuit design analysis. Overview of this video. In this video, we will explore the concept of analysis in electronics, covering various types such as circuit analysis, power integrity, signal integrity, thermal and electromagnetic analysis, and their importance in design and simulation. But what exactly is analysis in electronics and why is it so important? Let's break it down. Introduction to analysis in electronics. Analysis in electronics is the systematic study and evaluation of electronic circuits, systems, or components to understand their behavior under various conditions. It ensures performance, reliability, and compliance with design specifications. To fully grasp this concept, we need to understand the different types of analysis used in electronics. Major types of analysis. In electronics, analysis can be classified into several types, each addressing specific performance aspects of a circuit. First, let's start with circuit analysis, the most fundamental approach. Circuit analysis. Circuit analysis involves determining the voltages, currents, and other electrical parameters within a circuit to ensure proper functionality. Beyond circuit behavior, another critical aspect is power integrity. Power integrity analysis. Power integrity analysis evaluates power consumption and dissipation, ensuring efficiency and preventing overheating, while power integrity focuses on energy flow. Signal integrity ensures that data transmission remains clear and accurate. Signal integrity analysis. Signal integrity analysis ensures that data signals maintain quality as they traverse PCB traces, connectors, and interconnects. Along with power and signal concerns, we must also consider thermal effects and electromagnetic compatibility. Thermal and electromagnetic analysis. Thermal analysis studies heat generation and dissipation, while electromagnetic analysis focuses on minimizing interference and ensuring compatibility. To conduct these analyses effectively, engineers use different simulation settings tailored to specific needs. Simulation settings. Effective analysis requires various simulation settings, including DC, AC, transient, and noise analysis. These simulations play a crucial role in ensuring circuit performance and reliability. Importance of analysis. Analysis ensures performance, enhances reliability, optimizes design, speeds development, and ensures compliance with industry standards. And to perform such analysis, specialized tools and software are used across the industry. Tools for electronic analysis. Various tools are available for electronic analysis, such as SPICE simulators, EDA software, and multi-physics platforms. Mastering these tools and techniques helps engineers design better electronic systems. Conclusion. Analysis is a cornerstone of electronics design, enabling engineers to create reliable, efficient, and compliant systems. In our next video, we'll take this a step further by examining worst-case circuit analysis, a key technique for ensuring circuits perform reliably in extreme conditions. Stay tuned. Thank you for watching and stay tuned for more topics in our Back to Basics series.